Video 6. The Math Under the Hood, Technical Foundations. We have n observations. Each has predictors x, age, education, whatever, and an outcome y with some missing values. We split into y observed and y missing. We want to fill y missing. The model assumes y relates to x through linear regression. Y equals x times beta plus epsilon. Y is the outcome. X is the predictor matrix. Beta is coefficients, the weights describing how predictors affect Y. Epsilon is random noise. We estimate beta using ordinary least squares on complete cases. This gives beta hat, our estimated coefficients. Then we calculate predicted values for everyone. Y hat equals x times beta hat. For each missing case, we find the k-complete cases with closest y-hat values. Distance is just the absolute difference, simple one-dimensional distance. We randomly sample one donor and take their actual y value. What assumptions does this need? The big one is MAR, missing at random. This trips people up because the name is misleading. MAR doesn't mean data is randomly scattered. It means the probability of being missing depends on observed variables, not on the missing value itself. Example, if high earners are less likely to report income because their income is high, that violates MAR. That's MNAR, missing not at random. But if women are less likely to report income than men, regardless of actual income, that's MAR, because we can account for it using the observed variable, gender. If MAR holds and the regression model is correct, PMM produces consistent estimates. As sample size grows, estimates converge to true values. What about model misspecification? This is a PMM strength. Even if your regression is wrong, nonlinear relationships, missing predictors, you're still pulling real observed values. You won't get impossible values like negative salaries. The observed data bounds you. This semi-parametric property is why PMM is robust in practice, even when the underlying model isn't perfect. In the next video, we'll explore multiple imputation, why doing this more than once is actually the right approach.